Hi, good morning everyone. Today I would like to share with you a topic on the decimation, interpolation, and fractional delay. So in DSP, compression and expression of signal, we call it this decimation and interpolation. Whereas in the signal and system, we name it as time scaling. So decimation is the process of reducing the samples or reducing the sampling rate of a signal. So decimation can be done by sample at Ts at a continuous time signal xt. Okay, and convert it into a sequence of samples xn. So xn is xt sample as Ts. Okay. For example, if you have the signal of xn and the yn is equal to x2n. So this one actually is a compressed signal of x2t, sample at ts. Okay, this result in, let's say, n equal to 0. Okay, 2n, so you get at x0. And n equal to 1, 2 times 1, you get 2, so x2. And when n equal to 2, 2 times 2, you get 4, so x4. Okay, so alternate sample of xn. So this yn can be obtained by directly from the xt if we sample it at 2ts. Okay, so this means it's a two-fold reduction in the sampling rate. Decimation by a factor of n is sampling xt at interval nts. Okay, nts. So nts. Ts is the sampling rate, and imply the n-fold reduction in the sampling rate. So after you have learned the decimation, which is the decimation is the process of reducing the sampling rate, we go to the interpolation. We go to the process of interpolation. So interpolation indicates the increase of sampling rate. So just now decimation is decrease. So now is the increase of sampling rate. So this is denoted by the x n over 2. Okay, so which is the twice of the length of Sn with one new sample between the adjacent sample of Xn. So you have add up one new sample, okay, between the adjacent sample of Xn. So this means that if expression for Xn were known, it would be no problem to determine the new sample values. Otherwise, the best to do is to interpolate between the samples. There are a few types of sample types. Okay, you may choose either your zero interpolation, step interpolation, or linear interpolation. So what is the difference? If zero interpolation means that you zero pad, okay, you add in zero only. If step interpolation means that you add in a constant equal to the previous sample value. So if let's say previous value is 2, so the new sample also 2. If your previous sample is 5, then your new sample also 5. Okay, and then what about linear interpolation? If linear interpolation is the value is linear, let's say the previous one is 1, and then the next sample value is 3, so the new sample will be 2, so it's a linear. Okay, here are some rules. So if the signal xn is interpolated by n, okay, and then decimate by n also, and then the original signal xn will be recovered because you interpolate first, you increase the sample size first, and then you decimate means that you reduce the sample size, so the original signal can be recovered. But if you do the decimation first by n and then interpolate by n, the xn may not be recovered. This means that let's say there's a 1 xn value, and then you reduce the samples first. Reduce first. Okay? Reduce first, and means that there's some data will be cut out. And then you interpolate means that you increase the size, but in this case you won't be able to recover the original signals. So if both interpolation and decimation are required, it would be better to interpolate first because you increase the sample size. Here are some of the example for the interpolation. Let's say you have the xn equal to 1353. So generate 2n, x2n. So this one is the decimation. You reduce the sample size. So 3 and 3 because of the 2n here. Okay, 3 and 3, you get 2 value only. And then next question is generate the xn over 2 by using zero interpolation. So this one is the interpolation. So n over 2. So you means that you increase the sample size. So you add in zero interpolation, you pass the 0. So you have 1, 3, 5, 3. So 1, 3, in between, you add a 0. Okay? 3 and 5, in between, you add another 0. 5 and 3, in between, you pass another 0. Then after 3, you also pass another 0. Okay? So it's 0, this one is 0 padding, 0 interpolation. For step interpolation, this means that it's the same to the previous value. So you follow 1, the new sample is 1, then 3. Then new sample is follow the 3. Okay, then 5. New sample follow the previous one is 5. Then 3 again, so new sample follow the previous sample, 3. Okay. Another one is a linear interpolation. Linear interpolation is n divided by 2. Okay, n divided by 2 using the linear interpolation. So original is 1 and 3. So in between 1 and 3, linear is 1. New sample is 2. Between 3 and 5, you get 4. 5 and 3, you get 4 also. And 3 to what? This one always, last sample is interpolated to 0. So you get 1.5. So this is called linear interpolation. So let's consider the two sets of operation below. So xn is decimated by 2, you get x2n, and then followed by interpolated by 2, you get xn. And then xn interpolated by 2, so you interpolate, you increase the sample size, so xn over 2, and decimate, you reduce the size by 2, so you xn. So both operations appear to recover the xn. Looks like recover the xn. That's suggesting the interpolation and decimation in the inverse operation. But actually only this one, only the second sequence of operation, this means that you need to do the interpolation first, then followed by decimation, will recover the xn exactly. Okay. Now let's look at example. Given the xn is 1, 2, 6, 4, 8, and the origin is equal to 1. So calculate the two sequence of operations by using step interpolation. Okay, n over 2. So first of all, let's look at do the decimation first. Decimation means that reduce the sample size. 1, 2, 6, 1, 2, 6, 4, 8. So reduce the sample size by 2. So means that you jump 2 steps. So 1 and 6 and 8. Okay. And then followed by interpolate. Interpolate just now is using the step. So means that you follow 1, 1, 6, 6 and 8, 8. So you get the answer is 1, 1, 6, 6, 8, 8. Origin at 1. And then the same question, but you do the interpolation first. Interpolation using the step. So you have 1, 1, 2, 2, 6, 6, 4, 4, and 8, 8. Then followed by decimate. Okay, the decimate, you reduce the sample size by 2. So you choose 1, 2, 6, 4, 8. So this is the answer. So when you compare, actually only the B means the interpolate, then they're followed by decimate, you will get the same answer. If you decimate and then interpolate, you won't get back the same answer. This is the statement that I told you just now, in which you must do the interpolation, then decimate, then only you can recover the original signal. Okay, you understand? Class, this is the exercise, so please complete this exercise to increase your understanding of this topic. Next is the fractional delay. So fractional delay can be implemented using the interpolation and decimation. So fractional delay of xn require interpolation, shifting, and decimation. And in that order, this means that you need to follow the sequence. So first is interpolation first, then followed by shifting and decimation. Okay, so this is, for example, if you have the xn is look like this, so xn minus capital M over n. So if you multiply in, you get the so this one is the numerator and denominator. So this part is interpolate the xn by the n here, and then delay by m, then decimate by n, this one. So you need to follow the sequence. Now let's look at the example. Given the xn is 2, 4, 6, 8, and the origin is at the 6, calculate the signal yn equal to xn minus 0.5 using the linear interpolation. So first of all, you need to change the xn minus 0.5 into this format. Okay, into this format. So n minus 0.5 you can change to 2n minus 1 over 2. Okay, 2n minus 1 over 2. 1 over 2 you still remain the 0.5. Okay, like this. Okay, 2n minus 1 over 2. You change the format. Okay, then follow the sequence. So just now I told you you must interpolate by 2 first. Interpolate by 2, and then the question asks you is a linear interpolation. So the question is 2, 4, 6, 8. Okay, 2, 4, 6, 8, right? And then linear interpolation. So 2 and 4, the linear is 3. 4 and 6, linear is 5. 6 and 8, linear is 7. And add to 0. So your last sample is interpolated to 0. You get 4. So this is the linear interpolation, then followed by the delay. So delay by what? Delay by 1. Okay, delay by 1. So delay by 1, n minus 1. So n minus 1, you get what? So you get the, you use the latest answer from the previous. So means that you use the answer from the linear interpolation. So delay by 1. So you delay you use the origin method. So you delay. You shift 1 unit to the left. So you get 5 here. Okay, the origin at 5. Then decimation. Decimation, okay, decimation is 2n. So decimated by 2. Okay, you start from the origin. Where is the origin? 5 here, right? So 5, which number to take? So 3, 5, 8. 3, 5, 7, and 4. Okay, 3, 5, 7, and 4. So the which number to take, you cannot start from the 2, 2, 4, 6, 8. No, you have to include the origin. You must include the origin. So you're starting from the origin first. Where is the origin? So it's 5. So you get the value from the 5 first. Then here is 2. So you get the 3, 5, and then another 2. Interval is 7, and another one is 4. Okay, you understand? Okay, so don't forget you do the exercise on this exercise 1.5. Next, we look at the common discrete signals. Okay, you have three common discrete signals. That is the unit impulse, unit step, and unit ramp. Okay, what is unit impulse? Unit impulse, this means that is denoted by the symbol delta. and the value only at n equals 0. Okay, the value is 1. So it's 1 delta n. Okay, so at n equals 0, the value is 1. Other than that, the value are all zeros. Okay, for unit step, un. Okay, un at means that at n less than 0, the value is 0. And then for n more than equal 0, the value is 1. Okay. And then for unit step, for unit ramp, Rn. Okay, so the shape of the signal is ramp. For n less than 0, the value are all 0. For n more than or equal 0, the value start with n value. Okay, so it means that you have the 0, the ramp always start with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. The product, next is the property of the discrete impulse. So the product of the xn with the impulse delta n minus k. So this is the product of impulse result in xn delta n minus k equal to xk delta n minus k. So this is the impulse of the strength xk, and this product leads to the summation of the xn delta n minus k equal to xk. So this is the value of the amplitude. Sn actually is the value of amplitude, and delta n minus k is referred to when n equal to 0, and what is the value of Sn. When n equal to 2, what is the value of the Sn value? Okay. So actually this is the shifting property. The impulse extract the value of xk from the Sn at the impulse location n equal to k. So it's I told you just now is extract the amplitude value, the xk value from the xn. So signal representation by impulse. So any xn can be expressed as sum of the shifted impulse. Okay, delta n minus k. So this is the shifted impulse. Okay, shift because it's minus k here is a shifted impulse, whose strength sk correspond to the signal value at n equal to k. So the xn can be expressed as sum, the summation of the xn multiplied with the delta n minus k. So this is the shifted impulse. Un and Rn may be expressed as a trend of the shifted impulse also. Okay, so Un is a sum of the delta n minus k. So you add up all the delta, for example, delta 0, delta 1, delta 2, delta 3. Oh, so this one is, after you sum, you actually get a Un. So similar to the Rn, the RAM. Okay, so RAM is starting from 0, 1, 2, 3, 4, right? So K also the same. K is, for example, K is 1. Okay, delta n minus 1. So when n equal to 1, the value is 1. So when k equal to 2, when k equal to 2, so 2 delta n minus 2, the value is 2 at n equal to 2. Okay, so that is the shifted impulse. So discrete pulse signals, so there are two. One is a rectangular and another one is triangular. So rectangular, the rect, okay, rectangular signal, we name it the rect n over 2 capital N. Okay, so bear in mind that 2n here is the left hand side and the right hand side are the same. Okay, so you have 2n, like this is 2 times what? This 2 times 3. 1, 2, 3, 1, 2, 3. So 2 times 3. So rectangular n over 2 in the bracket 3. And then for the triangular signal, so n over capital N. Capital N is how many n? Here. How many n here? Okay, so this is the triangular signal. Okay, let's look at example. Mathematically describe the signals below in at least 2 different ways. So you have the xn here. For question A, you have the xn is 4213. Okay, 4213. Now let's look at the solution. So numeric sequence is 4213, xn equal to 4213. Where is the origin? If you check here, origin is at n equal to 0. You have 2. Okay, so the marker is at 2. Marker is at 2. And then sum of the shifted impulse. Okay, so you can write it in this way: 4 delta n plus 1. Why is n plus 1? Because the location. N plus 1 means the n is n plus 1 equal to 0, n equal to negative 1. N equal to negative 1. Okay, so the value is 4. And then n equal to 0, you have value of 2. When n equal to 1, you have the value of negative 1. And then when n equal to 2, so means that n minus 2 equal to 0, n equal to 2, at the location at n equal to 2, you have the amplitude of 3. So you have the 3 here. Okay. And then question 2, you have the yn equal to 0, 0, 2, 4, 6, 6, 6. Okay, the origin is at 0 with 0. So 0, 0, 2, 4, 6, 6, 6. So sum of the shifted impulse is, this is 0. So there's no value, but it's starting from here. So what is the n here? N equal to, this is 0, 1, 2. So n equal to 2. So n equal to 2 means that is n minus 2. So 2 delta n minus 2 plus 4 delta n minus 3 plus 6 delta n minus 4 plus 6 delta n minus 5 and plus 6 delta n minus 6. So this is for the sum of the shifted impulse. You also can do as a sum of the step and ramps. Okay, so how to solve if the question asks you to produce the answer with sum of the step and ramps. Okay, just now the question is, okay, what is the question? 0, 0, 2, 4, 6, 6, 6, right? So 0, 0, 2, 4, 6, 6, 6 is the question. Okay, first of all, how do you get the 2? First of all, how do you get the 2? If you go back to the question, it's 0, 0, 2, 4, 6. So this one actually is what? It's a ramp, right? It's a ramp. So you start with the ramp first, because since the question requires you using the unit step and ramp. Okay, how to get the 2, 4, 6? So means that you get 2Rn minus 1. At n equal to 1, you're starting the ramp. So you get the ramp, the amplitude is, you need the 2, 4, and 6, right? So you have 0, 2, 4, 6 at 10, 12, 14, 16. So this is the ramp for 2Rn minus 0 and minus 1. Okay, and then what else? So this one you have, this one also have, this one also have, this one you have 6. Okay, 0, 0, 2, 4, 6. And then number 5, what do you want for number 5? You want also 6. But your question is, the answer you provide at 2Rn minus 1, you have the value of 8. So you want to get 6, but now you have the value of 8. So how to get 6? You need to minus 1, minus 2, not minus 1, minus 2. So you minus 2Rn minus 4, because starting from n equal to 4, you want to start the ramp with 0, negative 2, negative 4, negative 6, right? So you have 0, 2, 4, 6, 8, 10. So you have the minus value. Okay, minus value. And then add minus 2, you get 6. Okay? Okay, this is what value you want. And the last part also you want to get 6. Okay, now you get what? 10 minus 4 is 6. Okay, correct. 10 minus 4 is 6, correct. And then this one, 10 minus 6 is 6. 6 minus 6, you get 0. No. 6 minus 12 minus 6, you get 6. But here is continue, you get 6. 14 minus 8, you get 6 also. 16 minus 10, you get another 6. So, but what you want is you want to make it stop. You want to get 0, 0, 0. But the answer you provide here, you get 6, 6, 6. So you need to throw up something. So you need to cut the 6 here. So you minus again negative 6. Okay, you minus again the 6. So you remove the 6 here by using unit step because you want it's a constant value. So negative 6 unit step n minus 7. Okay, so you remove the 6 here, you will get all the 0. So this is the value which is highlighted in the black color, is the value that you want. Also, you can represent this signal into a graphic. So this is when you view the graphic is like this. Okay, 2Rn minus 1 plus with negative 2Rn minus 4, and then plus with this one, and then you get the Yn. So this is in the graphic form. So either you can solve in the graphic form or in the table form. So it would be easier, or it's recommended to use the table form because it's easy to see. You don't need to draw. But if you use the graphic form, you need to draw. Somehow it's confusing. All right. Next, we look at the next question. Numeric sequence, if you have 2, 4, 6, 4, 2. Okay, if you use the sum of the shifted impulse, that is easy. So you starting from here is 0, negative 1, negative 2. So 2n plus 2, you get the amplitude of 2. And then for n equal to negative 1, means that is n plus 1. The amplitude is 4. And then delta n is 6. And then 4n minus 1 is 6, is 4. And then plus with 2, delta n minus 2 is 2. So sum of the step and ramps. So in order to get 2, 4, 6, you use the ramp. Okay. This one is starting from negative 3 because bear in mind that the ramp always start with 0. So 0, 2, 4, 6. So you get negative, you start from negative 3. Okay. 2, 4, 6, 8, 10, 12, 14, 16. And then this is you get what you want, and after this you want the 4 and 2. Okay, this one I want to get the answer of 4. But how to get 4 is 8 minus 4, you get 4. Okay, 8 minus 4, you get 4. And then 10 minus 8, you get 2. Okay, 12 minus 12, you get 0. So you get value of 420. So you minus with the 4 ramp so that you can get the value of 42. Okay, 8 minus 4, you get 4. 10 minus 8, you get 2. So you minus the 4 ramp. Okay. And then the last part is the remaining 14 minus 16, you get negative 2. And then 16 minus 20, you get negative 4. This one you also can cancel out using the ramp. Okay. So you negative 2, how to cancel out? You need to plus with 2. So, and this one you need to plus with 4. So this one you can use the ramp is 2Rn minus 3. Okay, starting from 3, 0, 2, 4. So you can get the answer, desired answer. Okay, 2, 0, 2, 4, 6, 4, 2. So this actually is a triangular function. okay, and 6 is the maximum value, so 6 triangular, n over 3, so it's 1 2 3 1 2 3. So this is the exercise that you can try at home. Next is the discrete system, a process in an input xt to produce an output yt. You know what is system? So system is a process, the input xt to produce the output yt. Okay, so you need one is input, and then you have a system, and then produce the output. Okay, so the input to the system is so-called a cost to the system, whereas the output of system can be considered as the effect of the system. All right. So the system are modeled as a transformation or operator that map the input signal to the output. So in the signal and system, we use a continuous time, the xt, okay, then txt. In discrete time, which is in signal processing, we use the yn and then txn. The dot here is denoted the operator or transformation that models the effect of system on the input signal. And then we have few system classes. So classes of system are defined by the following characteristic, such as the memory. So memory, what is memory? Memory system is the system has the ability to store the information about the input from the past or future value. And then linearity, okay? Linearity is must satisfy the homogeneity properties, okay? And then time invariant. So system is time invariant when the input output characteristic does not change with time. And then next is the causality. Causality is the output depends on the present input and past input and do not depends on future input. So that is the causality. And stability is the bounded input, bounded output. So all this is the classes of the system. Next is the linear time invariant system. So linear time invariant system, we need to fulfill the three properties, such as must exhibit the additive property, and then must satisfy the homogeneous property, and also must combine into the property of superposition. So that is the LTI system. For an LTI system, the input delta n will come out the output of hash n. Input of delta n minus k, the output is after the trend of the impulse is the hash n minus k. Similarly to the xk delta n minus k, you will get x4 delta n minus k, you will get has x4 hash n minus k. So all this is referred to the xn, and this one is the yn. So it means that before the input signal xn insert into an LTI system, so the LTI system you need the input. So all this input is the xn, and then to produce the output, and this output is the yn. So the output can be expressed like this: yn equal to the summation of the xk hash n minus k. So in a short notation, you can write yn equal to xn convolute with the hash n. So this one we name it as a convolution process. So once the hash n of the system is known, then given any input xn, we can always compute the output sequence yn. So in the convolution, it's quite common for you to see hash n minus k. So this one is what? This hash n minus k actually is equal to hash negative k minus n. So this hash k is about the reflect the hash k about the origin to obtain the hash minus k. Okay, and then shift the origin of the reflected sequence to k equal to n. So somehow now it's very hard for you to understand. Later on we have the example which is easy for you to understand in the later chapter. Next, I introduce to you the correlation signals. So this one is the operation. Similarly, the operation of the correlation is similar to the convolution. It involves also the sliding one function passed to another, and there's no folding. Okay, so there are two types of correlation. Either is autocorrelation, another one is the cross correlation. So autocorrelation is the same. This means that correlation of two identical functions and center at t equals 0. So rxx. So rxx is the same, so autocorrelation with it. So xt, if you look at the xx, means that xt correlation with the xt. Okay, that you have double this symbol, that one is correlation. If only one, that is a convolution. Okay, so in the formula in form is integration from minus infinity to infinity, x lambda minus d lambda. So if in cross correlation, that one is the rxy. You see the symbol also is different. Rxy, so it's a cross, different, two different functions. Okay, so xt cross correlation with the yt. Rxy also same as ryx. It is the same. Okay. So as a conclusion, we can say that the autocorrelation is always even symmetric with a maximum at the origin, in which the rxx, the autocorrelation rxxt is equal to xt correlation with the xt, or xt convoluted with the x negative t, or equivalent to rxx negative t, which is less than the rx 0. Okay, so that's all for the chapter 1. So thank you for the watching. Thank you.